So today we are going to cover these topics.
Ah,
This is our main module, you can say 5,
okay.
and the data modeling and storage decision.
Ah,
Okay. And the structured data, which we need to cover.
okay.
Structured data for scale,
Okay.
read heavy versus
Okay.
write heavy system,
Okay.
consistency, availability, and partitioning,
Okay.
data lifecycle, and retention.
Okay.
So, hand over to you. Just tell me what you understand from this first. This
Okay. Okay. Oh, that is one data modeling and storage decisions. Okay. Structuring data for scale. Okay, fine. Structuring the data for scale. Mm, okay. Structuring the data for scale. Okay. What I can think of, what I've experienced is today there are 100 users. Tomorrow, let's say we have got millions of users. So now the how the scalability has to be planned is instead of having everything in one table, I'll be having many tables, and also I'll structure in such a way that uh, partition the data. One is partitioning, and then indexing, uh, then replications. So in this way, I structure the data so that during the scalability, it should not affect my operations. It has to work like how it is working for 100 users. So instead of putting everything in one, yes, I will split the tables. I'll have the relationships based on some key concepts of some important columns. Based on that, I structure my data so that the application runs efficiently, either while searching or bringing in the products. All that that is one part. Then that is not the only part, but one part is make the data flow such a way that you get all the response within set time limits.
so basically, as per my understanding, if you talk about the structuring data for scale,
Uh,
means right now whatever means you are targeting, let's say 1,000 users,
uh,
1,000 lakh.
uh,
Okay,
mm,
so you are targeting for that, but your structure should be solid.
uh, uh, uh,
If you go for scale, then there is no need. That time we don't require to change any schema things. We
mm,
need no need to change for any decision. Hey, this not just for class scale.
mm,
So me, you can think of when you are planning a city, when you are planning a, you can say any this city society.
mm,
Then you need to take a head and think about a future as well,
mm, mm, mm,
what it will do and how it will accommodate, if
mm,
means a crowd means when person will join, or
mm,
means start living in a society
mm,
or
mm,
city.
mm,
Make sense?
right.
You need to plan ahead.
Mm, mm, mm,
Otherwise, means if you not plan, if you planning for right now only,
mm,
and you are not means thinking about ahead, means when this traffic will increase, when
mm,
load will increase, what
mm,
happened.
mm.
So that's why it's required.
Okay, okay.
You understand my point?
Right, 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 right.
We cannot say, hey, when that happened, then we will see that.
We will see. No, we have to pay everything right from day one only. We should plan for all these things.
Yes, that's all about this this architect or design, system
Oh,
design.
okay.
Make sense?
Yeah, right.
So what is this?
Read heavy versus write heavy. Okay, fine. Um, Read heavy is nothing but let's say now. like the huge number of users are accessing my application data. There, the right reading is heavy, whereas right in case if you take the example of a boutique system, it is purely read heavy system because I am not having too much of writing there. Yes, probably I may have more products and more products. So I may add it once in a while. So writing is happening once in a while, whereas reading is always full-time activity. Whereas if you take other systems, say the financial data or ERP data, something like that. There, for example, let us say somebody is capturing the weather data, online map data. So where the writing will be happening heavily. Read will be a little less, but writing will be more. The too much of data is getting captured. There it will be the write heavy system. Whereas if you take my boutique system, or if you take example of a famous e-commerce site, Amazon.com, it is more of read heavy rather than write heavy. As they keep updating the products, but still, overall percentage if you take, it is more of read heavy than write heavy. In case of the other like weather data or map data, it is going to be write heavy and less of read heavy systems.
Okay, why we need to care? How you understand what is the meaning of this? Am I
Ah,
right? And
ah.
you explain that why we need to care of this.
No, because see, this also affects my performance. Read heavy means for every user, say the moment they click on the products or when they're viewing the products, definitely I can't load all the products in one page. So there'll be multi-page. So when I navigate between the pages, it should say within some 20, 30 milliseconds, it has to load the data. So it has to read and then bring the data up. So it cannot go on, dragging for user to go on waiting. So yes, so that means I have to plan for my users that the moment they click on the next page, it has to load immediately. So that will be the read heavy. So it has to be read heavy. Right. For example, when you take map example, when I'm traveling with GPS data, it has to quickly, write
I understand.
ah,
Sorry to interrupt. I understand. You know the things.
ah,
You
ah,
know the meaning of read heavy and write heavy.
ah,
I am asking why these matter and what advantage we will get if, let's say, talk about this read heavy. You
ah,
understand. You require read heavy.
ah,
Okay. So why you first question, why you need to know it's a read heavy, write heavy. I need to know those points. Why you require that? One point you told me it's good for a client because
ah,
so that you can serve better.
yes,
But
yes,
and you can say means we cannot wait, means client cannot wait for
I
long.
can't wait, yes, yes,
Apart from that, how what you can think and what how means another point are you thinking means hey means if we know this in a well in advance and then we will get these
ah,
benefit.
yes,
Why means which benefit you are gonna get and means how what you are thinking about this. Let's read heavy is there.
okay,
Now you understand my point.
got it. Okay, one, let me just think now. Right heavy, why we need is a question. Mm,
What advantage, what planning you are gonna do there? What will advantage if you will get this answer?
hmm,
Which type of data is a both or it's a hybrid? It's a you can say read heavily, write heavily.
ah,
If you get the answer, what is your next approach after getting the answer of these? Makes sense.
right.
Because you are require the answer of this. There should be some meaning. Am I
Correct.
right?
I got the point. So what I told was technical point of view. Now you're expecting the other answer from me. I know. Uh, See, okay, one word is performance. Definitely, to improve the performance, we have to plan accordingly. Uh, and also, will it affect my cost? Yeah, I think it's going to affect my cost. If it takes more time to load, and definitely that is going to cost me. So for that reason, I have to plan it. But otherwise, one is performance. Okay, the other one, why we need to.
Simple term,
Hmm,
let's say you will take an example of your restaurant.
okay.
And means we can say when dining is there, this is right heavy. And one is you can say delivery is there, then it's a read heavy.
Hmm,
Makes sense. Think
ah,
about this. Am I
ah,
right?
okay.
So if there is a delivery is heavy thing, then we need to plan everything accordingly.
Ah,
We need to means whatever we can prepare well in advance.
ah, right.
I am right.
Ah, right.
And whatever you require means on an instant, like means chopping, means just wrapping or just
Hmm,
filling the things and preparing with a full this.
hmm,
So that means we need to, if you will get the answer
ah,
early
ah,
about this, that based on that we can prepare the thing. Like
ah,
in
right.
a read heavy, you can say you can apply a multiple, you can arrange a multiple counter,
Okay, okay.
and you can say store something which is an instant available, and you can deliver. You can put this on your table only,
Ah, ah, ah.
reception table, so that you can deliver quickly. Makes sense.
Okay, okay, okay.
Like in terms of our application, we have a cache there, CDN is there.
Hmm,
Am I
hmm,
right?
hmm,
So
hmm,
based
hmm.
on that, you can do very easily.
Okay,
Am I
okay.
right? And
Okay.
right heavily means, then if you know means it's a right heavily is
Hmm,
there.
hmm, hmm, hmm,
So means what approach you will take there,
hmm,
means
hmm,
what
hmm.
kind of means how quickly you can, how means it will store
Hmm.
easily.
Okay, okay.
Am I right?
Right.
So if after this getting the answer of this, you can go with those things.
Hmm, hmm. Okay,
Makes
okay.
sense.
Okay.
And that's why I'm saying I need to work on your, I'm working on your mindset only.
Hmm, hmm. Okay, 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 okay,
Okay. So
okay.
you need to think ahead.
Uh-huh.
Okay. So now consistency, availability, and partitioning. You need to discuss in this context of this only, not generic context.
Oh,
Makes sense.
okay, okay, okay.
Consistent Consistency, availability, and partitioning.
Okay, consistency is nothing but whatever data I read, um, it has to be consistent. That covers, for example, whatever writing I do and whatever I wrote, that only I should get. So their consistency has to be maintained. And performance-wise, if my query is bringing the data within 20 milliseconds, that has to be consistent throughout, either 100 users or million users. That has to be very, very consistent. And then availability is today, if you take multi-region, multi-continent works, applications, it has to be available anytime. There's no, I can't say only from 9 to 5 it is available, after that it is not available, I cannot say. So whenever the user wants, either anytime, morning, evening, night, anytime he wants, my system or my data should be available to him. That is availability. And then partitioning. This little technical. Instead of storing all the data, entire data in one database, sorry, in yeah, in maybe in one table. Technically, there is a feature where I can partition the data, so my query will become very efficient. So partition can be based on region, year, product, category, various things are there. So based on that, I partition it. So my performance or the output to the user will be quick enough for him to take a decision. It won't make him wait. The decision will be taken quickly, and also the maintenance of the database will become easy for me. And tomorrow, if one partition goes down, my application will be still running. I can still manage the show in the background, do the necessary updates for that partition, and then continue the work. So in this way, I think overall it's going to help my application in many ways by having the consistency, then availability and partition.
Yes, so you're right. So simple term, consistency means if we are serving a food, the taste is a consistent. It
Ah,
cannot be vary for one
every day.
order
Ah,
and
okay.
second. It cannot be vary.
Correct.
If user is able to see two on your website, it should be every user should be able to see two only. It
Ah, ah,
cannot be three. This is a
correct.
consistency.
Right, right.
Availability, as you know, means if it should be available, so
Ah, right,
that user can interact
right,
anytime.
right.
Partitioning, you are also correct there. Means partitioning, we are doing in a partition.
Ah, yes.
So rather than means one user is interested for only, but this your you can say
Mm,
uh, lady suit. Why
mm,
you
mm,
will why you will force him to go for me check first gents
mm, mm.
gents clothing. Am I right?
Right,
So there's a partitioning.
right.
Now we need to move ahead for this data lifecycle and retention. What is that and why we require that?
Okay, data life cycle. Retention is nothing but whatever data is entered or updated, that has to be retained. This one. And the data life cycle, I can say like how the data flows through different stages. Um, So the data flow, like for example, I create the data, or not like that, sorry. Data flow, okay, yeah, no, I think, okay, data flow is nothing but say now the user logs in, and then,
No.
oh,
Hold
no,
on. Hold
okay,
on.
okay.
This
So,
is understand this
ah,
data life cycle and retention. This is not a data flow. This is
okay.
a life cycle.
Oh, this is data life cycle and retention. Okay, retention I know, but data life cycle.
That is the life cycle of human being. What is
Mm,
the life cycle of water? What is the life cycle of you can say animal, dog? Everyone have its own life cycle. Am I right?
mm.
So data also have a life cycle.
1 minute. Okay. So here, nothing should be technical. Data life cycle.
Like when data will creation till deletion.
Deletion. Okay. Okay.
Okay, so
Oh,
this is a life cycle.
oh, okay. Okay.
And retention means how much time
Hmm.
you need, how much time you want to retain that
In the
data.
data. Right. Okay. Okay.
Makes sense.
Correct.
2 years, for 2 years you want to retain that
Hmm, hmm,
data.
hmm, hmm,
5 years, six
hmm,
years.
hmm.
Makes sense.
Right.
This is
Retention. Yeah. Okay.
retention.
Okay. Okay.
Makes sense.
Okay. Okay. Okay.
So are you clear? Could we go with the theory part?
You explained nicely. Okay. There is an important topic and very simple examples you gave. Now I'm clear.
Okay, let's check this. Sorry. Yes. So data modeling and
Ah,
storage decision. Why this module is covered in depth?
okay.
Data modeling is the core of
Hmm.
system design.
Okay. Okay.
Most scalability, performance, and reliability failures happen due to bad data
Hmm.
design,
Right.
not bad code.
Hmm. Hmm. Hmm.
This module builds your ability to design data, structure, and scale,
Scale. That's
choose
scale.
correct storage system,
Hmm.
optimize read write performance,
Hmm.
handle consistency trade-off,
Hmm. Hmm.
manage data lifecycle.
Right. Right.
Okay.
Okay.
So structuring first, we discussed this. Now
Hmm.
we are going through a theory part.
Okay.
So designing schema
Hmm.
that can handle growth,
Ah.
traffic, data plus traffic.
Okay.
Makes sense.
Without reading.
Without without
That's most
revision.
important.
Yes. Okay.
Right.
Poor structure lead to
Ah.
slow queries,
Having joints.
heavy joins,
Right. Locking.
locking issues,
Yeah. Scaling.
scaling bottleneck.
Right. Right. Right.
Before, when we need to perform this activity,
Ah.
this is also important.
Very important. Yes.
Yes, choosing databases,
Hmm.
writing schema,
Hmm.
designing API.
APIs. Right.
If you don't have this answer, how you can do that? Am
Correct.
I right?
Yes. Yes. Yes.
Like this food delivery analogy, bad.
Hmm.
One row update repeatedly
Hmm.
is a bottleneck.
Yeah. Correct.
Okay, good. Append only order
Hmm.
events,
Hmm.
scalable.
Right. Right.
Engineer thinking, bad model, mutable.
Can change it.
Yes, like this.
Okay, so orders table, ID, status, updated at problem. Okay, row locking, then high contention, difficult to scale. Okay, 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 okay. Good modeling, immutable, yes. Order ID, status, and then timestamp. Oh, updated times. Okay, fine. So append only. Okay, I'm only adding it here. And then no locking, correct. Then easy scaling, then audit friendly. Yeah, correct.
So here you are able to see this is a this is a immutable.
Ah, ah,
That's a mutable.
ah, ah, ah.
And this is a thumb rule. When you go with this, you will always try to, if possible, go with a mutable thing. So
Ah.
you have a better control.
Mm,
Now this is a visual diagram.
mm.
You can think of this is a cart created, item one added,
Item,
two added,
item one to
assistant.
go,
Yes,
then shipping information added, then event store. Okay, then.
yes.
Okay, and then materialized. Okay, this is for the data. Okay, warehouse thing, cart ID or customer ID. External system application, either for example, payment, delivery, all that are external systems. And then query for current state of entries. Okay.
So this is a other example.
Okay. Okay. Users queries, process storage, database ledger, append only ledger table, view. Okay, fine.
Make sense?
Yes.
So block and one and two. So this is other example.
Oh, beautiful. Okay.
Basket service,
Hmm.
order requested, payment process, order service, shipping service. So this matters.
Hmm. Hmm. Hmm.
Makes sense. What is a mutable database? BS system to record application data used in a mission critical
Business
business
process.
process.
Fine.
Store repository business data.
Okay.
Store history of change of data.
Hmm.
Mission critical.
Right.
Run at a scale.
Hmm.
Support verification consistency of data over time.
Hmm.
So this is event based. Event is a log are
Okay.
mapped logically to streams
Streams. Okay.
and immutable data.
Log. Okay.
So as you know, means it's a mutable.
Hmm.
You cannot change the data.
Ah, yeah. Immutable. Yes.
So rule design for write as event,
Ah,
not update.
updates. Yeah. Correct.
Okay. Now you understand
Ah, yes.
mutability and immutability.
Hmm. 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 Hmm.
Design for write as a event.
Hmm. Hmm. Ah, read.
Read
Okay.
read
More right.
however.
More
Yes.
right than read. Correct. Okay. Here what we need different systems need different optimization. Okay, read heavy optimization cache and replication. Right, write heavy is queues and batching. Okay, this very important term. Okay, fine. Okay, when user behavior traffic patterns. Okay, fine. Right.
You are able to understand why I'm is
Yes, 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 yes.
because based on this you need to take a decision.
Correct.
Means you can the client request in this field as well. We need to take a decision further.
Hmm, hmm,
Means
hmm.
user can wait or he cannot wait.
Hmm, hmm,
If
hmm, hmm.
if he can wait, then we can club all these things in a batch and then go for processing.
Right.
If we require instant, then we can put everything in a queue
Hmm,
and
hmm,
serve one by one.
hmm, 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 hmm.
Am I right?
Right.
After understanding user behavior, traffic pattern,
It's okay.
user behavior and traffic pattern,
Right.
use cases, Mino browsing, read
Right
heavy,
heavy, correct. Order placement, right heavy. Correct. Okay.
which we discussed. Am I
Right.
right?
Right.
Engineering
Uh, read.
thinking, read optimization,
Okay.
cache,
Redis
read
replica.
replicas.
Okay. Denormalization. Yes.
Yes. So
Oh,
write
okay,
operation.
okay. Generally, we speak about normalization, but at times we need denormalization also. Okay. That is to avoid joins, heavy joins. So if we have repeated data in different tables, I did not go for a join. I can run the query. Fine. But most of the time we talk only about normalization, but here it is denormalization.
Yes. So basically, rather than going here and there,
Yes.
if
Only one
we
place we
have,
take.
if some, we will get on a one table,
Ah,
that's a good for us. I mean,
yes.
right? It's a good for client.
Yes, correct.
So means that's why I'm saying. And right optimization,
Mm.
queue,
You
Kafka, batch right.
conflict handling. Okay.
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 Now this is a visual. So application server
Mm.
and your read write,
Okay.
primary synchronous replication,
Right.
read replica,
Right.
read only by
Right.
reporting application server.
Right.
This is a replica, is a primary one, read and write, and
Okay.
this is a read replica.
Right.
So means you can think of our restaurant app. They
Okay.
are preparing everything for this. Means if they want to do
Ah.
read and this, they can have their own kitchen. Am I right?
Okay. Right.
But if user this is a kind of counter,
Ah.
delivery counter, where they just means request for order and they will deliver. That's it. Am I right?
Correct. Okay.
And this is your caching with the Radish.
Okay. Oh,
Okay.
Redis. In fact, I have not seen Redis application at all. Okay. Fine. Right. Redis. Okay.
So it's a cache server.
Oh. Okay. Okay. Okay.
Okay, it's nothing. It's a cache server,
Okay.
and based on that, you will means until unless there is a new thing which is not available on a counter, then
Mm-hmm.
you go for a kitchen. Then you will check a kitchen.
Oh. Okay. 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 Ah.
Otherwise there is no need to do anything. It
Mm-hmm.
will first check at counter only.
Mm-hmm. Mm-hmm. Okay.
Simple term.
Oh. Okay. Fine. Right.
So now it's a NA10.
Mm.
NA10 is a you can say uh, you have a one, you can say this server, and it can do, means it's serving a multiple application
Oh, okay,
with
okay.
the help of AI
Oh,
automation.
okay, 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 okay.
So, and this is a master node writes and slave node
Hmm,
reads.
hmm, hmm,
Makes sense.
hmm.
So all are means telling us, hey, this matters.
Ah, 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 ah.
Okay.
Okay, okay.
Now this is a rule. Optimize based on a dominant operation,
Um,
read versus write.
read, all right. Okay, fine. Okay.
Now we need to this
Okay.
cap thinking.
Cap theorem. Okay, fine. Okay, consistency, availability, and partitioning. Oh, okay, fine. So consistency same data everywhere, right? Availability, yeah, system always responds. Partition system scales across the nodes. Yeah, beautiful. Okay. Why? Distributed systems cannot guarantee all three. Oh, 1 minute. Distributed systems cannot guarantee all three simultaneously. 1 minute. So here I have a doubt now. See, for me, I have to, there's a trade-off. Do I need consistency or
No,
availability?
no,
No?
don't go there. Don't go there. Just you understand the distributor system. You are
Uh,
not on one person is not means responsible for everything. Now it's a shared responsibility.
oh, shared responsibility. Okay.
Distributed system, but what is the mean of distributed? Mean they have a shared responsibility.
Okay. Okay.
Makes sense.
Okay.
If they have a shared responsibility, if bowler is not playing well, if
Ah.
batter is not doing the things
Hmm.
right,
Hmm.
then we cannot take a guarantee there.
Okay.
Makes sense.
Oh.
Guarantee all this simultaneously.
Hmm.
Now you understand?
Okay. 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 Okay.
So this is crucial
Yeah, very, very crucial. Yes, correct.
because when if something means how we can keep those things in a sync. All
Hmm.
these systems should be in a sync.
Hmm.
Okay.
Right. Right.
If that's the only monolithic approach and if you can say single person is responsible, you can just need to take care of that person only.
Ha. Ha.
But in a distributor system, we need to take care of
Hmm.
all the components.
Right. 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 Right.
Design distribute system, choosing
Hmm.
database, planning, scaling.
Uh, but here, Deepak, when you say choosing database, no, see, I should know the pros and cons or the features of a database. Only when I know all these things, then I can go for a decision. For example, let's say we have Oracle database or we have NoSQL we have nowadays, and then DynamoDB. There's example Redis, maybe, I don't know. So unless I know what are the what to say, not the benefits, what are the uh, 1 minute. See the purpose of this, why there are so many databases, uh, and what are the strengths and weaknesses of a database. Only when I know that, I can think, okay, I should go for this, I could go for that. Otherwise, for everything, I cannot use same Oracle database or RDBMS. So now,
Yeah.
uh,
Yes,
as a data architect, how will I gain this knowledge? How will I get to know that? So should I update my knowledge, read about I mean, go to the documentation of those databases, understand its features, and then take a call, or how? I mean, can you just explain to me about that?
yes, definitely. Because everything have a meaning of their existence.
Ah, ah,
Means earlier we have only SQL. Now no SQL comes in a picture.
hmm.
Then graph comes in a picture.
Graph, vector database.
Neo4j.
Hmm.
I know Neo4j. I'm certified there. Okay.
Hmm.
So means definitely if you need to know and definitely you need to study. There is no shortcut.
No choice. Okay.
You need to study.
Because if I want to give a solution to the customer, I need to know about it. I can't blindly tell something somewhere read and then say, okay, boss, use this. I cannot tell because that may be very crucial decision. Tomorrow, my whole application, this application may fail. Right? So the need, as you understood, means I should know the strengths of the database, why it is designed in such a way. For example, no SQL, why no SQL came into picture, why vector database is used. So all that strengths of that DB product I should know. Then only I can suggest go for this, go for that. Right?
Definitely.
Okay.
If, same thing with when we go next, then you know means when we need to take a decision for this technology stack in a
Ah,
system design,
mm,
data, why we go over this.
mm, mm, mm,
That's required.
mm.
Makes sense.
Ah,
Because so many languages are available, so
yeah.
many databases are available.
Yes, yes.
If you don't have a knowledge, how you can take a
Yeah,
decision?
correct. That's what, yes.
Makes sense.
Yes, correct.
This is that's why I'm saying this is a high level things
Mm,
which will give you a means reasoning so that you can reason. But when
mm,
you go for reasoning, then your mind will juggle and they
mm,
will come up like this kind of question.
mm.
Raise means junior mind.
Ah,
Hey, I don't know this database thing.
yeah.
I need to know that.
Ah,
And I need to know this DevOps thing.
ah.
Why? What is the advantage of this cache and what other options are available in the
Yes, yes,
market?
yes.
So it's a starting only.
Ah, okay,
Makes sense.
okay, okay, okay.
You need to be consistent in your learning.
Oh, yo,
Sridhar.
yes, 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 yes. I realized it long back.
Yes, means you need to be consistent there.
Yes,
There is no shortcut.
no shortcut, no shortcut. This very well realized this. That's why I always keep on joining for the courses.
But you have required a better mentor who
Mm,
can guide you
mm, mm,
in a
mm.
better direction.
Right, right, right. Got it, got it. Okay.
So now payment,
Yeah, correct. Whatever I update, that should remain there. It should be consistent. Or stock, when I update an inventory, everybody should choose the same inventory. One cannot see 10, one cannot see 5 here and there. So it should be consistent. Correct. Nice example again.
yes.
Tailor tracking, yeah, correct. Eventual consistency. Yes. Okay. Here, okay. Engineering thinking, payment. No, 1 minute. Engineering thinking, payments.
No
No.
inconsistency allowed.
Oh, inconsistency. I was reading it as consistency. I was wondering what is this? Okay. So inconsistency. Okay, okay, okay.
Not
Oh,
allowed.
yeah, correct.
No
Definitely not allowed.
inconsistency allowed.
Not allowed. Yes.
Small delay acceptable.
Acceptable. Correct. Yes.
So cap theorem, every read receive the most recent right. Am I right?
Every read, receives the most recent right. Perfect. Yes. Okay.
Every request receive a response.
Response. Okay.
So this is system continue to operate despite network partition.
Partitions. Right. Okay.
So strong versus eventual consistent.
Eventual. Okay.
So here you are able to see
Hmm.
this is a you can say right
Hmm.
node one
Hmm.
and right means propagator through cluster
Clusters.
node two
Ah.
and internal knowledge
Acknowledgement happens
means
between those
knowledge
two. Ah.
is acknowledged. Hey, I received
Acknowledgement.
this.
Correct.
And after that, what it will do, this acknowledge to
Implement
the
the
client
client.
because it's means it's available on a both. Require live majority always return
Latest.
latest right.
Hmm.
Event consistent. Right now, this client
Okay.
and here and third is
Invention.
this
Ah.
right propagation.
Hmm.
High available right must commute.
So here,
And
node 2 is not sending the acknowledgement. That means we don't need immediate acknowledgement. That's the meaning, is it? See, in
yes,
particular,
yes, yes.
okay, okay, right.
It's a event based.
Hmm.
Here is you can say it's sending and waiting for acknowledgement. It's not
Hmm.
waiting for acknowledgement.
Hmm. 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 Hmm.
Makes sense.
Okay, okay, okay.
And acknowledge to the client.
Hmm. Hmm. Hmm.
Event right propagation.
Right.
So you can think you are always in a mode. Hey, I can get something. I can
Ah,
get something,
yeah, yeah, yeah.
and you are ready for that only.
Yeah, right, right.
You are prepared for that only.
Correct.
Here is trained for to give a confirmation,
Yeah,
and
okay.
which we earlier discussed, I think so. Is
Ah,
just wait.
ah,
In a synchronization, it will wait for confirmation.
okay.
Event, it will not wait.
Okay, 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 okay.
Make sense?
Right.
Different type of consistent mode, string eventual consistency, casual consistency.
Oh,
Cannot see the
okay.
updated data immediately.
Mm-hmm.
All node eventually reflect the same data.
Eventually.
Operation are seen in the order they are issued.
Mm,
Read read your writes consistently. User always see their updated.
immediately.
So these are lot of things.
That's what. Yes, a lot of things are there. Okay, fine. Okay.
But you need to go step by step,
Ah,
and you need to go with a plan.
ah.
So, rule, not all data needs strong
Yeah,
consistency.
right. Correct.
Partitioning, sharding.
This
These are
what is partitioning? What is sharding?
it's the same thing you can say.
Oh, is it
Partition.
okay? Okay.
Splitting data across multiple nodes.
Nodes. Okay.
Okay. Single DB cannot handle massive traffic, large
Mm,
databases.
right.
As I told you in a simple term, you are opening multiple counters
Right.
to serve your customers.
Okay.
Okay. So multiple customers are there, multiple counters are there. They can serve easily.
Right.
In your this events like a marathon or things, marathon, they have a multiple counters. Makes sense
Mm.
because that time they know means crowd is there, so we require
Mm.
like this massive traffic,
Ah,
large data set.
right.
When TB CPU is high, queries slow down,
Ah.
vertical scaling fails.
Mm.
Vertical, what do you understand for vertical scaling?
That is, say one system. Say I may go on increasing the storage capacity or the RAM capacity, cache capacity. The vertically I'm scaling the system. When I say horizontal, I add more CPUs, more
CPUs,
systems. I add more system to spread across. That is horizontal. Vertical is same. For example, one system, I go on increasing the this one, like some memory, storage, or all that.
yes. So strategy, hash based, range based, geo based.
Ah,
Okay.
okay,
And the use cases, order split by user ID, region, order by.
okay.
So you are able to see this.
Oh, beautiful picture. Okay, fine. Oh, local global index. Okay. Rebalancing request routing. Okay.
But
Partition. Oh, okay. You're clubbing, like clustering the partition. For example, like three partitions to one. Oh, okay. That is sharding. Okay, that is shard one. Then four in front, another shard. Okay. Oh, logical shards. Six logical shards. Okay. User. Uh,
post comment,
Post comments. Okay.
logical,
Okay.
shard key,
Ah,
hash function,
okay.
so shard 1, shard 2,
Okay.
data sharding,
Okay.
partition and appliance sharding. So
Ah,
there are a lot of things out there.
ah.
Partition before hitting bottleneck.
Ah.
Makes sense.
Right.
You can say spend some time on a daily basis for your health or well-being
Ah.
rather than spending a time in a hospital
Hmm.
when you are ill.
Hmm.
Makes sense.
Right, correct.
Okay, now data lifecycle and retention.
Retention. Okay.
What do you
Oh,
understand from this?
okay, okay, yeah, okay. Creation, usage, archive, deletion. Oh, beautiful. Okay, fine, right.
So
Yeah,
could you explain this to me? What
yes.
do you understand
Okay.
from this?
Yeah, beautiful. I got it now. Okay.
Please
Ah,
explain these four terms.
mm, right.
Just explain me what you understand from this.
Okay, for example, now I create a product. Okay, that's because I want to now sell some products. So I create those products in my app. That is the creation part of it. Once I put it in my app, all the users will use that product. Okay, now let us say tomorrow I remove some of the products. Now let's say those products are outdated, no more in need. People are going for a better products. So what I need to do, I have to remove them and store it for some more time. So I archive it. Then finally, maybe my policy says in my store, any product I create should be retained for next 2 years. That's my policy. So I keep it for 2 years. I archive it for store it for 2 years. After 2 years, I'm going to remove that product entirely from my database. That is deletion. So okay, this is the life cycle of data, right? Correct?
Yes, archive means their retention policy is fine,
Ah,
but apart from retention policy, we need have a policy as well, or rules as well.
ah,
Hey, this is a product,
ah.
and but this product is no more required by a client, or we
Clients
are not. You can say
selling or
we are going to suspend this from
ah,
our store,
ah, ah,
or you can think of you are maintaining the history of the user,
correct.
and you will tell them, hey, if means some cases your payment history we
Ah,
will retain
ah, ah,
for after 1 year it goes to archive.
correct.
Makes sense. So that if there is some deviation or
Ah,
some problem there,
ah,
you have your data stored in a means under lock.
ah,
Makes sense.
ah.
It's there.
Yes.
If you want to retrieve, you can retrieve that. But
Mm,
for
mm,
that, you need to take extra step.
correct.
It's a costly one, but it's
Mm, mm,
there.
mm,
So
mm, mm.
there should be some rule.
Ah,
Make sense?
right.
So reduce cost, improve performance,
Mm,
meet compliance.
ah,
Because this is for compliance.
ah,
If
ah,
you know that, then you can do that. Am I
ah,
right?
ah, ah, ah.
After defining
Mm.
business requirement,
Mm.
legal policies,
Okay.
analytical
Right,
needs,
right, right, right.
active order, primary DB,
Mm, mm, mm.
completed over archive,
Okay, okay.
analytics warehouse.
Right,
Okay.
right.
So this is some example.
Okay.
So this is a, you can say tire
Mm,
mission critical,
mm,
tire
mm,
one,
mm, mm.
tire two hot,
Oh, yes.
warm,
Mm.
cold.
Okay, 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 okay.
Cold means archive.
Deleted. Done.
No,
Ah,
archive. Archive
archive. Okay. So what is warm in that case? I was thinking warm is archive. What is warm?
means which is not frequently required,
Okay, 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 okay.
but it's required, but
Ah,
not frequently.
not frequently. Okay, fine. Okay.
Makes sense. This is
Okay.
means not required,
Mm-hmm.
and means it should be there.
Okay.
You cannot delete.
Okay, 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 okay.
Create a retention policy. Assign
Okay.
ownership, documents approved, understand legal requirement, determine needs. Makes sense.
Mm, mm.
Establish internal audit.
Right,
Okay.
right, right.
So this here you can say sources like these are the Excel, databases, Salesforce, cloud.
Mm.
So lake means it will use to store whatever data they just store it. Just store it.
Okay, 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 okay.
And warehousing means we are doing this sorting and things. And after that, whatever after filtering or organizing, categorizing data, we are giving serving to a team
Mm-hmm, mm-hmm, mm.
for different use cases.
Right, right, right.
Okay, data pipeline
Pipeline.
component,
Okay.
region, data flow, and destination.
Okay. Okay.
Makes sense?
Right. Right.
Cold, warm, hot. You can say hot means
Mm.
instant require.
Instant requirement. Okay.
Warm means sometime they can call if
Okay.
they are using. You can say
Ah,
data lake, store everything and anything.
unknown. Okay. Question.
Unknown question with unknown answer, unstructured,
Okay.
data mining, data science,
Okay.
data warehouse, warm, data
Okay.
warehouse, data metric,
Wow.
marks prepared for an entity analytics, known
Right.
question and unknown answer, regular refreshed business concept,
Right.
in
Right.
memory computing,
Okay. Okay. Okay.
pre-computed aggregation,
Okay.
data lake, common mistake. So these are the common mistake. Too many joins,
Hmm.
no indexing, no partitioning,
Hmm. Hmm. Hmm.
data engineering flow,
Hmm.
identify assess pattern, classify read versus write, design schema. So choose DB, add cache queue based on your operation,
Hmm.
plan
Hmm.
partitioning, define consistency,
Hmm.
define life.
Okay. Okay. Okay.
Okay.
Okay.
So all these available for you
Okay.
and
Okay.
Mino, cache, this visual.
Okay.
Okay. And this is a Kafka example as well.
Okay. Okay.
And as you know, we have this
Okay.
questions
Right. Right. Right.
and this is a storytelling.
Okay. Okay.
Okay.
Right.
Let me stop the recording.